It's kind of cool. You got this green energy boat being pulled across a desert. It's got windmills and solar panels and 2 donkeys. I wonder what those represent. Saying, fortunately, the blinders are working. And you see the voter pulling it along. The important point here is the blinders, okay? Now, Western countries have been so dumbed down by the climate fraud, and that's what I'm going to talk about a little bit, not in depth because we don't have a lot of time, that we accept the unnecessary hardships imposed upon us. When we get there, I will talk to you about 2 that have been imposed. Well, one's a result of the other. One I mentioned before is the CLCPA. Okay, that's the Climate Leadership and Community Protection Act. Okay, they're protecting us by filling our lives with useless windmills and stuff. So we'll get there, and I'll talk at the very end about the NYSERDA feasibility study on the windmills wind turbines, sorry, in Lake Erie. We'll get there. So anyway, so we're going to talk to this thing about net zero. You ever hear about net zero? It means zero carbon, right?
Yeah.
And, okay, sorry, being an engineer of many, many years and doing a lot of system design, I can tell you, Alice is returning to Wonderland, okay? So that's what we're going to talk about to start, what that is. So now we're going to talk about Alice versus Wonderland science, okay? So Alice is speaking to the Queen. Remember Alice in Wonderland? She says, "One can't believe impossible things." The Queen replies to her, "I dare say you haven't had much practice believing impossible things. When I was younger, I always practiced believing impossible things for a half hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast." Welcome to modern politics. So, before we get into this, I gotta say, there's some people that made this presentation possible. I want to thank them. And thanks to them and the trillions of dollars they've put into both social policy and energy technology. You have, and you've probably seen this already, the trans-electric stove, okay? It was born a gas stove, but through the miracles of, I don't know, gender morphology, it's now an electric stove. So, okay, now I want to put climate fraud into context. I'm going to do this. The most powerful method I know is satire. So I'm going to borrow from one of the best satirists I've ever seen, Andrew Klavan. Put yourself back October when that hurricane hit Florida, okay? And what did you hear? "Oh my God, it's climate, climate, climate." No hurricane ever hit Florida before. So anyway, let's start here. If useless measures are not quickly put into place to do nothing about climate change, we will soon be faced with an emergency situation in which hurricanes continue to strike the Gulf Coast as they have done every year in human memory. Gets better. Okay? According to green experts, climate change has caused these hurricanes and other storms to intensify to exactly the same level they were before. Now there are far more climate catastrophes reported than there were before climate catastrophes were reported.
Right. That's right.
As a result, whereas in the 1920s nearly 500,000 people were killed yearly in climate-related disasters, last year that number rose dramatically to 7,000. So if we fail to act soon, Al Gore's most dire predictions will come true and the world will be destroyed 10 years ago. Remember, he predicted by 2014 all the archives would be gone. We'll cover that. By 2020, our coastal cities would be flooded, island nations would be underwater, and Barack Obama would not have bought those two $30 million worth of houses on the ocean. Okay. So, real quick, we talked about science versus the science before. I'll review it very quickly, okay? Science requires the application of the scientific method to separate that which is demonstrably false from that which might be true. Most people don't get it. Science never proves anything true. It tells you what's false. You formulate a hypothesis, a theory, and then you go test it. And either you say, okay, I accept the theory because the test didn't falsify it, or if it didn't pass the test, you say that theory's wrong. Okay? That's science. The science, who uses the word the science? Who claimed to be the science? Fauci. I'm the science.
That's right.
This is like the biggest farce of all. They should call him Farsi. Anyway, the science means to reject scientific method altogether, and it relies on a couple logical fallacies. If you remember, Ken Erickson was here. He talked about logical fallacies. Let's just use 2 of those. Thank you, Ken. He borrowed my book. Anyway, one is the logical fallacy of reference to authority. Experts say. Now, how many experts predicted the Bills would win on Sunday? How many experts predicted Cincinnati would win on Sunday? I chose Cincinnati because it's my money. But that being said, so experts say, okay, that's a fallacy. There's no scientific method in experts say. That's just pure conjecture. Okay. The next, logical fallacy of majority view. This one you hear all the time. The consensus is. Well, you know, when Albert Einstein came up with his original theory of relativity, there was 100 of the world's top physicists all had consensus that Einstein was loose in the head, right? He was totally wrong. He was really, because then he formulated his second theory. The first one became the special theory, the second one became the general theory of relativity, and that's where we are now. But we'll someday find out that there might be something wrong too, right? But we haven't figured it out, but that's where we are. We got a theory. And where theories or hypotheses stand, we call that a scientific law. Okay? Good enough. If you can't, you've had it forever and you can't disprove it, then it becomes a law. But it's axiomatic. It can be proved wrong if you can find the way. Okay, last part of this, the so-called scientists deliver what the governments pay for. The government, if anybody's ever, I implore you to do this if you haven't done it, go back and get on YouTube and look for Dwight Eisenhower's 1961, January 17th speech, farewell speech. Everybody remembers the thing about the military-industrial complex. Nobody remembers that he said the danger, that's just one example, the danger is letting government control science because now we become the Soviet Union. Okay? And they did that in the Soviet Union. They had all kinds of stuff that was phony science, especially in the social sciences, right? Harder to fake it in physics. But that being said, so the government says, well, we want you to show that we're in climate catastrophe. Great, you're going to get it. So what happens? The very best of our climate scientists, no more grants for them. And in science, grants everything, right? So, that being said, go with this. Booker T. Washington, who knew about BS, said a lie doesn't become truth, wrong doesn't become right, and evil doesn't become good just because it's accepted by a majority.
That's right.
That's a really good statement of the difference between real science and the science. So that being said, there's another one here. Richard Feynman was one of America's top scientists in the 20th century. His deal was physics. Particle physics, and he said, religion is a culture of faith. Yes. Beautiful. Science is a culture of doubt. Yes. Science has to be skeptical. It's not about belief, right? That's religion. Okay? It's about skepticism, and that's what scientific method is. So carry that with you next time somebody tells you about science. All right, now I want to talk about the fraud that's behind net zero. Remember, we said net zero is that idea that somehow we can just magically get rid of all carbon, right? It's decarbonization and work there. And this is gonna get slightly technical, but not real technical. Everything in here I could probably teach to a 6th grade or so. Anyway, so remember the experts say that CO2 is a control knob on global temperature causing human catastrophes unseen before. Everybody ever hear Al Gore? It's the control knob. Okay. He's over there in Davos right now saying the same thing. Okay, so we're going to ask this question. I'm going to go through some stuff very quickly. You're going to get this report. You can check it out later. Call me, ask me questions. I got to show you this stuff fairly quickly. Okay, the question is, does CO2 drive temperature? So if you look at this plot, it looks a little messy. You see all this red stuff going up and down, okay? That's actual reconstructed temperatures for the last 350 years. You can see the date, 1659, 2009. Okay, then there's a black line that's less squiggly. That's a running average, 11-year running average, okay? Just a technique you use, it's called smoothing data, all right? The dotted line you see there is for the last 300 years, and that's a trend line, okay? It's a linear trend line. So it says, where have we gone in the last 300 years? What's happened to the temperature in the last 300 years? It's gone up naturally, since the Little Ice Age, right? By the way, the Little Ice Age is where, if you guys are like beer and hard liquor, if it wasn't for the Little Ice Age, you'd still be drinking wine. Because in the Little Ice Age, it wiped out all the grapes in Northern Europe, and they had to find another way to make booze. Fact. Okay? And England used to be was a big producer of wine during the Roman times. Can't grow wine grapes there anymore. Too cold. Right? That being said, now I want to draw your attention to something else. You see this thing that says MMCO2? Okay, that's man-made CO2. That's the amount of carbon dioxide that's been dumped into the atmosphere in what is it, I forgot, billions of metric tons, okay? Since we started doing that, which, you know, back in the 1800s, Industrial Revolution, you can see it's gone up fairly high in the last, 50 years, really high. But you don't see a corresponding bump in the temperature, do you?
No.
You do not. And I'll show you another plot where it says, we're even going downhill. So, now that doesn't prove there is a relationship between CO2, it is a greenhouse gas, but its effect is so minor and so small that you can't even measure it, okay? But anyway, so let's move on. So, your takeaway, CO2 is not a primary cause, okay? If you need just one thing to remember, CO2 is not a primary cause. Okay, this is recent global temperature rise. Oops.
Where?
This is total Earth temperature. Okay, so they have a composite. So the bulk temperature of the Earth, and this goes 2015, 2022. This is just recent. Now there's all the data. It's month by month data over 7 years. But do you notice the trend line on there?
Yeah, a little bit.
We're burning up. The Earth has a temperature. We're all gonna die. All right. Anyway, so. Your conclusion here, your takeaway, well, there's no evidence of warming at all since 2015. And this is very accurate data, right? It's taken from all kinds of surveys of ocean. It's ocean plus atmospheric temperatures. It's all tropospheric temperature measured by satellites, very accurate. So, whereas in the past, they had surface measurement, surface temperature measured from thermometers. Most of those thermometers don't even exist anymore. So what they do is they fake data to put it in there. Literally, they're called what's those dead people that walk around? Zombie thermometers. Zombie thermometers. And then they fake it. They literally fake the data.
Wow.
So they can put anything they want in there and then say, oh my God, look at the temperatures. So anyway, okay, it doesn't look like there's any evidence in the last 15 years. Arctic sea ice. Okay? This would get your head going up and down and up. All right, what this is from 2006 to 2022. This is I think this is originally done like on a like every other day or something like that basis, okay? But what you see, the blue line going up and down, that's winter to summer, winter to summer, winter to summer. So you expect a lot more Arctic ice in the winter, all right? And a lot less in the summer. So let's focus on the blue again. Look at 2014. Did that ice disappear? Our expert Al Gore was wrong. Stuff on him. Anyway, the red line is just a 365-day running average on there, so it just gives you the trend. And if you look from side to side, there's no discernible trend that's in there. If you ran a linear regression line through it, it would be straight through. So anyway, your takeaway? No, sea ice is not melting away. And by the way, Arctic sea ice melting does not raise the ocean, right? Why? Put an ice cube in your cup of water, right? Let it melt. Did it raise the level of the water? No. Okay, so another little piece of BS that by having the world's worst math and science education, we do, and most expensive, we've managed to BS people. All right, are tropical storms getting stronger? Now, tropical storms include hurricanes. Okay, hurricane is a tropical storm with sustained winds over 75. Okay, and miles per hour. Who needs kilometers? Sure, we can do that. Anyway, so if you look at the data from 1970 to 2022, and this is the time period where we've had the explosion of carbon dioxide, right? And if you look at that across the top row, do you see any trend? No, it's just normal. It's what we call noise in data, right? The bottom row, which is just hurricanes, right? The bottom layer is just the hurricanes, right? Because there are going to be fewer hurricanes than there are tropical storms. Right? Because hurricanes are tropical storms at bigger speed. Okay, so if you look across the bottom, what do you see? No trend. No trend. So your takeaway here is when they tell you that your tropical storms and hurricanes are getting worse, the data does not support it. So if your hypothesis is that carbon dioxide, or whatever, is driving the climate into these types of into disasters, worse storms, the data says, no, it's not. Your hypothesis is wrong, start over. That's science, okay? It's scientific method, literally, that's a scientific method. And anybody ever here get like a cake recipe or cookie recipe, and you bake them and it didn't come out the way you wanted them the first time? and then you experiment it, maybe a little more heat, a little less heat, you know, blah, blah, blah. You're using scientific method. And you could have put a technical report together once you got it right. But you didn't want to share the recipe with my wife. So, all right, anyway, tornadoes, same story here. This is getting old, right? More frequent or stronger? This is easy, last 50 years. Okay, what's the trend line? Is there anybody here that doesn't get this stuff, the graphs? I mean, seriously, if you can read your tax investment stuff, I mean, your investment stuff from Wall Street, you can read this. So. Anyway, so that's interesting. So the trend has actually been down. Now, this is F3 to F6 tornadoes. That's a scale. They don't put F1, F2 in there, but those are lower power ones because you can't always, you can catch them on Doppler radar, modern Doppler radar. Back before year 2000, you couldn't see them, and you'd only know they were there if there were people there to witness them, okay? Whereas a bigger storms like F3, you'd know they're there because everything's correct. So anyway, so notice also, when were the most storms? What year is it? Can you tell, kind of? Let me help you out. 1974. What was also going on in the news in 1974? Anybody remember? Global cooling, thank you.
Yes.
Right? We're all going to freeze to death. And here's why. Tornadoes, 90% of which exist in the United States. Okay? The rest of the world doesn't have many tornadoes. Okay? They happen when cold Arctic air comes down and meets warm air coming up from the Gulf. Right? That's why you see them in Alabama recently, right? Cold air coming down, you get that mining cold. And I'll be right to you, Scott. So what happens is you have this clash. Storm intensity is higher when you have greater temperature differential. Right? That's why you see really bad storms, because it's a warm front, it's really warm. The next day it's like 15 degrees out. And that bad storm you had, that's because of the mixing of warm and cold, Scott.
This is a good question. The data you're showing, which I believe is correct, who's producing it? Because on the news right now, we're hearing the last 6 or 7 years were 4 of the warmest ever. So I'm just curious what.
Okay.
That's what I'm asking.
I can tell you this, and in the bonus slides at the end that I don't have time to go over here,
Okay.
you'll see how I have slides in there about how the government has manipulated the data. It's fake data. In other words, they took, and I can show you that later, or at the conclusion of this. Anybody wants to see it, I will. But the other thing is, the data that I'm using comes from NOAA.
Yes.
NOAA. Okay. So the problem is that with the way they package information, and like for instance the IPCC, which is UN's intergovernmental panel. Well, intergovernmental means it's political, not scientific. The science at the lower level is pretty good. The trouble is, by the time it filters up to the political executive reports, that's gone.
So you're basically saying NOAA has good data, but it's being manipulated.
They have good data, but I'll show you another place where they also try to hide it. We'll get into that in just a second. So it's very dishonest. I mean, you're paying literally paying billions of dollars, and it will cost you trillions because of it for government corruption. So anyway, so conclusion: tornadoes are neither more frequent nor stronger. Moving on. Are forest fires getting worse? Now I'm going to answer the question about fake data. Okay, 1926 to 2018, I showed some other dates in there that aren't pertinent. If I look across that entire spectrum of that, when is the highest burn acres? This is bare burn acreage. Where's the highest burn acreage, left side or right side? Okay, and you would say that maybe on the left side, over here, I don't know if you can see the mouse, that's about 4 times as high as 2018? About, okay. Now see that part in the pink?
Yep.
The government erases that from the websites. You're not allowed to see it. When you go on the website, or like when you get those things from Facebook and it says see the temperature in your area, they only go back to the 50s, and there's a good reason for that. But anyway, so let's go back. So if I look at this data, 1982 and forward, okay, the right-hand side, the low burn acres was 1982, okay? From there. Now if I go forward, 2018, what happened in the 90s? Anybody remember about having to do anything with how we manage forests? Not allowed to take out underbrush.
That's right.
Okay? That was Clinton in the 90s. So look just to the right of 1982. You see where it starts to increase? So it is true, the forest fire acreage is doubled from 1982. Is it because of CO2? No, it's because now you have really wicked forest fires, because you didn't allow it to be cleaned out. In the meantime, you hide all the data back in the 20s and 30s. By the way, one of the worst heat waves, there was two really bad, were killers. Like 120 degrees in Boston, Massachusetts. That was like 1911 and 1921. Those were killer heat waves around the world. And by the way, every year they say, "Oh my God, Australia's in a flood. Oh my God, we're going to die the next year. So we're in a drought. There's a flood and a drought." If you look back at the history of Australia since they kept the data since 1940 or 1846, drought, flood, drought, flood, drought. They don't have average weather. They have drought, flood, drought, flood. Anyway, sea level rise. Okay, this is past 150 years. This is from the records from in New York City, called the Battery, place there. And if you look at that, knowing that CO2 is spiking over on the right-hand side of the curve, right? Because we're looking between 1850 and 2020. You probably can't see that. Okay, I'm sorry, I didn't put those dates. So left side is 1850, right side is 2020. Kind of linear, right? Steady rate. What did we see earlier about the global temperature rise the last 300 years? Now, there's other data that goes back behind this that verifies it even back 200 years, I think 200, 250 years ago, they have sea level rise data, okay? It's all linear. I mean, it's going straight. So there's no corresponding uptick in sea level rise with carbon dioxide rise. There's a real good reason for that, by the way. I don't go into that here, but I do have a slide that shows it. It's one of the bonuses. So anyway, so there you go. We're all gonna be underneath water, right? By 2050, we're gonna be under 20 feet of water on the coast. Well, that sea level's it's between, depending on where you go, because sometimes the earth is going up, sometimes going down. But on average, the sea level rise is about 2.5 to 3 millimeters a year. Okay, that's not a whole lot. A foot a century, something like that. But that's been going on since forever. So that's not CO2 doing that. Okay, are more people dying from disasters?
No.
Remember Clavin? In 1920, 500,000 people were dying every year. Now it's risen to 7,000. So, you just got to look at the data. 1900 to 2010, where's the biggest death tolls from climate disasters? The 20s. Remember, I said 1921 was probably the hottest on record. They changed the data to make it look like it's not, but that's when it was. So, anyway.
Get all these data.
From NOAA, and I get it from a couple places. One is John Christie, who's the head of the National Climate Center, and the other is Tony Heller, who used to work at the National Climate Center. He's where I get most of the data. And John Christie, by the way, we're working on that, getting him to ABC Chautauqua. Is it in? It's in? Victory dance, because I made the initial conversation with him, and since I did my second master's degree at the University of Alabama at Huntsville, which is where the Climate Center is, he said, "Oh, anything for an alumni." So, anyway, I'm finally somebody, and my wife will fix that. Okay, so the last one, all climate models over-predict temperature. Okay, you're told climate models this, models that. First of all the model is a mathematical representation of the hypothesis. A hypothesis is just a mathematical statement of your theory, okay? So, if the model doesn't match the real world data, what does it mean? Your hypothesis is wrong, right? So, bring your attention to, just to everything, why not? See the thing at the bottom, it says data says? There's 3 data sets along the bottom. Remember, the world's temperature is increasing, right? We established that. That's been naturally increasing. Okay, and if you look at those data sets, some's taken by balloon, some are by satellite, okay? And they do some magic to average those, So that's what the real data says, going back to 1975 and up to almost the present day, 2020. Now, if you take the model, mathematical model, computers are never wrong, yes, but programmers are. The program, I should say, is, look at the red line, that's the average of the IPCC models. There's 32 IPCC models that are in use. And they all have different assumptions around them, different parameterizations, a fancy way to say they're all different in some way, okay? And they're all estimates. Models are always estimates. They're never the real thing. It's the map is not the territory, right? So if you look at that red line, that's the average of those models, and that's what they use. And you'll see that there's just a little bit of difference between the reality, the real world, and up here. And they're going to tell you, oh my God, the temperature's going to jump 6 degrees Celsius by 2100. Well, not quite, okay? But, and indeed, the IPCC says, do not, even in their literature says, do not use these models for making policy predictions or policy judgments. And then you turn around and use them for making policy judgments. So I mean, IPCC is, I got a bunch of lunatics, I don't know. So, conclusion, hypothesis that CO2 controls temperature is absolutely wrong. Okay, Al Gore, you can have your nod back. So, which leads us to this. That was a long way of getting to this point. Climate catastrophism, right? And you see fear used everywhere. The Jews are going to kill everybody in Germany, so we got to kill them first, right? Fear. You got to be afraid, all right? And I'll tell you what, anybody follow Robert Malone, he's on this big time now, because this was used extensively in COVID, right? The technique. But anyway, climate catastrophism, belief in a narrative based on intentional perversion of science in order to nudge, and that's an important word, the population into giving up their freedom, empowering the government to protect them from an imaginary catastrophe. Now I want to look at that word nudge, you know? I could go, all right, I can nudge. That has a very specific meaning in psychological operations. I want to call it psyops in the military. Everywhere else knows as propaganda. Okay? I put a link here in this presentation. You can go to it. That is the United Nations Climate Nudging Document. It tells you exactly how they're going to nudge you psychologically. England has nudgers throughout their government, not just climate, for everything. So if they're trying to push you in a direction, you ever watch TV, watch an ad. Watch what you're being hit with every day. You're being nudged, all right? And they're trying to normalize what you don't think is normal, right? That's why you look at TV, I turn the TV off, I can't watch it anymore. So anyway, but that's, I would suggest you looked at nudging up, okay? And I also put a link there to, I don't know if anybody's seen it, it's a guy named Freddie Sayers has a weekly podcast called Unheard. He started it at the beginning of COVID. It's been excellent. He's had all the best people on there. Anyway, he has a discussion there on the use of emergencies to control people. And remember, in North Korea, the Americans are coming for your babies, so you darn well better fight the Americans. Same thing. Okay, now, we're going to get a little bit technical here, okay? Now we're going to get away from climate catastrophism. They use the climate catastrophe to get you to buy into what we're going to get into here is net zero. But we can't understand the problems of net zero unless we understand baseload power and how this grid would work with all this wind and solar stuff. Okay? So, baseload power is very simple. If I was to say, I have my daily power needs, okay? I say this is days along the bottom, and this goes off all year, and it might be a repeating pattern. They know the patterns for every area, right? And they plan their power output accordingly. Okay, and then the power along the left side going up and down is continuous. That can be any level you want. You know, I normalize it at 1 unit of power, continuous power. Okay, is where I decided to put what I'm going to call my base load power. I need to have that every single day. Right? Now it might go up or down. If you're down south, you got a warm day, it might need more air conditioning. Right? Cold day up north, it might need more heat, whatever. We'll need a lot more electricity in the future. Anyway, so that's what baseload power is, okay? Now the key here is that when you use fossil fuels, hydro, nuclear, they're perfect for baseload power. First of all, they're steady, they're reliable, they love to run at a steady level, especially nuclear. And of course, you know, the power coming from Niagara Falls is going to be pretty steady, all right? The others are like if you have natural gas fired, you can boost it up or down if you need to. Coal likes to stay pretty much the same. But anyway, those conventional methods of power, and that's why we've had such great power up until now in this country, is we've had very steady production, okay? Now, let's introduce some wind and solar to the grid. I'm pretty sure most people have seen this before, okay? Now I'm going to put this graph up here again, and I'm going to show you what happens typically when you introduce wind and solar, which are intermittent, right? Some days are good, some days are bad, and we even talk German, okay? All right, so base load power, I'm going back to the same example. That's the base load power we have, Okay, now let's say we're doing what Germany did, or where Germany is right now. They think they're going to net zero. They're on average maybe getting 25 to 30% from renewables, but that's on average. They've had as high as 46, a couple good days, lots of wind and lots of sun, but really bad days, because in the wintertime, it's calmer there and cooler, and then the sun's low, right? So how much power you can get varies a lot. So the black at the bottom of the bars in the bar chart is wind and solar, WNS. And the gray stuff right there is what you need for backup, okay? Now, here we get to speak German, das Deutsch, das Dunkelflaute. Goes along with Mel's presentation. Dunkelflaute. Much snow. Anyway, so Dunkelflaute is it's literally a German word, and it means dark doldrums, or dark and calm. Okay? What I showed there is that, I don't know, let's say we're day 9, whatever, there is all gray. That means there was no wind and solar. Okay? So that means we need to be able to have power for that. Okay, now we're not talking yet about batteries, that really gets ugly, but, well, next slide, but let's talk about that. So some days have no wind and no solar, and grid requires 100% or more fossil fuel backup. They had 100% fossil fuel backup in Texas when they had that problem too. Trouble is none of it actually worked because it froze up. So you also need reliability, so you need more than 100% backup, which we typically have around here in our old systems. That being said, so you can't get rid of your fossil fuel or your other backup systems. You still need them to back this up. Now the problem is you're paying for both systems, and when you have a system going up and down and up and down, a lot of the older ones, they don't like to go up and down in temperature. The new co-cycle plants for cogeneration plants with natural gas don't mind that. They're made for that. But most of the other ones, they don't like to be cycled up and down. And sometimes it takes a really long time to, like coal, to get them up and get them down. So it's problematic. And the really dirty part of the story is the law from the federal, the original federal legislation that sets up these subsidies, that all your ISOs, independent system operators, like NYISO has to do, they're forced to buy first the wind and solar, which at a very elevated price, and then they can only backfill with these other things. That's why the price of energy's gone so high, where they've introduced it. So anyway, so let's move on. So let's look at this scenario, net zero, 100% wind and solar, okay? So we'll come back to our fancy drawing. We still have the base load level that we need. And what I've done is I said, okay, let's just say we put in lots of wind and solar. Okay, so some days we've got a surplus, right? Sitting up there, what are we gonna do with that? Germany either dumps it or pays other people to take it, believe it or not. Because there's so much. If that stuff's spinning, you can't overload the grid with that power, so you have to dump it. There's another term for it, I forget what it's called, curtailment. Or you can dump it into batteries. So that's where we're gonna go here. Okay, so the gray area down here is where you'd have to do battery backup day to day to day. Some days you got extra wind and solar, but most days you don't. So you need battery backup. This is where it gets really expensive. So, remember you still have that day of das Dunkelflaute. Can't get away from it. Oh, and by the way, those periods, when they plan this, can be up to 30 days depending on where you are. Be up to 30 days of storage. Now you can see where the price of batteries is going, right? To store that much power. So the question is, how big and expensive must their battery backup be to enable net zero? That's a big question. And you can't ever say about, in general, you can write an equation, but for any specific location, you have to take into account the local conditions. And do you get weird things happening, right? If you get a extended Dunkelflaute, you know, das große Dunkelflaute, then you're in real trouble. So anyway, so I'm going to real quick introduce the source of all your problems. Okay? The New York State CLCPA, you've heard it. It's the Climate Leadership and Community Protection Act.
Oh, it feels so good.
Right, yeah. So that was I'm pretty sure that Cuomo signed this to improve his credentials for the next presidential election, right? His leftist credentials, no doubt. And that's why we're paying for it. That being said, the bottom line is this. The CLCPA sets impossible goals like net zero, and I'll show you why it's impossible in a realistic sense. It's theoretically possible if you could get all the stuff you need, in which case there'd be nothing left of the planet. And CLCPA is definitely a license for the state to transfer your wealth to well-connected investors. You see the amount of subsidies that are going into this stuff, and you don't see the federal subsidy. You see the debt going up, but you're not tying that to every time that windmill turns, your wallet just got emptied, right? Every soak of the ray of golden sunshine that hits a collector plate out here is empty in your pocket, because you have to pay for that first, and it's more expensive. Right? So. Well, I said this before, policy, not politics, no, okay, policy. A nice policy would be, we need to repeal the CLCPA, or there'll never be any sanity in our energy policy, okay? Oh, and off the cuff remark, just this week they announced in China that they're now producing commercially small modular nuclear reactors, which they can just put out everywhere, make them in a factory, drag them out there, hook them together like batteries and let them run. They're not doing wind and solar, but we're buying all their crap. Right? Check it out. And the high price of electricity here will drive and wait till you see the industry, even whatever's left of industry in New York is gone if they go through with the CLCPA. So anyway, let's look at the scenarios of the consequences if we go to net zero, okay? You mentioned Indian Point earlier, okay? That's a 3.2 gigawatt reactor. Just to make it easy, I made it 3,200 megawatts. All right, a gigawatt's 1,000 megawatts. All right, that being said, so they killed that reactor. That's a lot of power down there. It's on the Hudson, it's feeding New York City. Okay, so they have the transmission lines from there to New York City that powers it great. They're a lot heavier, obviously, than the transmission lines that go through the backbone of upstate New York. Because our power is distributed, not in one spot. That being said, if you're going to replace those with 3 megawatt turbines on Lake Erie, now I mentioned 3 megawatt nameplate. The nameplate rating, when they say, I'm going to put up a 5 megawatt turbine, that's the amount of power it can put out under perfect conditions 24/7, 365. That never happens. So for instance, on Lake Erie, if you look at a solar farm out here, you're going to get, somebody mentioned one before, it was 15%. Yeah, I'm surprised it's even that, but they say typically they advertise that they're going to get 20%, 20 to 25. You get better out in Arizona, a lot worse here, obviously. The sun's lower in the sky, you don't get much of it. That being said, so if you have I was quiet for you now. Anyway, if you were going to replace with 3 megawatt, which would be the size they were proposing out there, okay, if you're going to replace them, each one actually puts out, let's be generous, 1 megawatt, right? Because you have about 30% efficiency factor, right? So, gives you 1 megawatt of output for each one of those windmills. Now, we need 3,200 megawatts to replace. We have to replace that down at Indian Point. Now, simple math, if I take 3,200 and divide it by 1, you too, if you go to MIT. So you need 3,200 Lake Erie turbines to generate enough power to replace that output. But that's assuming they're running all the time. You don't have that Stuckelflaute. Okay? Okay? Now, we're going to assume 10 days. 10 Tage. Das Stuckelflaute. Okay? You need, oh my gosh, 3,200 megawatts. Now, if you're not a physics major, that's okay. Times 24 hours a day, times 10 days of storage. Now, you probably don't know what this number means. Okay, 7,680,000 megawatt hours of energy storage. That's a little bit bigger than the battery in here. Okay? Okay? So, now what it means to us, I said, you know what, let's just stop and say, okay, this is impossible. Where are you going to get all the materials to make these batteries? Lithium batteries, cobalt, stuff like that. You know, the blood cobalt that little kids are mining over in Africa. And then, where are we going to get it for New York State? Where are you going to get it for the rest of the world? Right? For the Western world, just committing suicide. Right? China ain't doing this, so they're not that stupid. So, realities of net zero. We can't make enough batteries to store the power. Okay? The example we were showing is just it's a small fraction for New York State. Just a tiny, it's a speck on the map. Okay, we don't have enough copper to rebuild the grid backbone to get the power from here down there. Let's say they put those windmills on Lake Erie, and they're gonna have the power outtake at Dunker. Now I gotta get the power from there, because it's gotta replace the stuff downstate, right? We don't have enough copper lines to get that. You need a certain amount of copper, and who's an electrician? Has anybody ever here zap themselves, you know, a little about blowing a breaker? Now you know, you don't have enough copper to get the power down there without burning everything up.
The other problem is if they're on the lake, there's no infrastructure in the lake to get the power to the
Right,
coastline.
that's,
So that's a whole nother issue.
how did you know that I was gonna put that up next?
Because I lived in New England when they did Cape Wind.
Yeah,
And the
yeah.
cost to bring
Yeah.
the power
Right.
from out in Nantucket
Yep.
back into the coast.
Yep, and here is the dirty secret, when they tell you what the cost of power would be, the estimates, they do not include the cost of interconnections in the backbone.
That's correct.
That's the big lie. Talk about the big lie. Alright,
So they
now here's another one, the
underestimate that.
cost of batteries is about 20 times the cost of turbines. Okay? So, and remember, when we go back up, batteries, every 10 years to replace them, they don't last forever, and they degrade every year. So you don't, it's not just every 10 years you replace them, you're constantly in a replacement mode, okay? And the turbines, 10 to 12 years, and they'll get, especially on the lake, they'll get beat up, the ice will really be nasty, and that may be one of the other reasons they decided not to go with it. But anyway, so, and the last one is, and I don't mind using the RAPE word, we will need to rape the environment to mine the materials for net zero. All the windmills, all the batteries, except the copper, is going to destroy. And then, of course, what do they do, like cut down, like Scotland, 2 years ago, cut down 26 million acres of, no, 26 million trees to put up, that otherwise sequester carbon dioxide. They put up they cut down all those trees to put up solar panels and wind. Crazy. So anyway, the bottom line economic analysis is this. California net zero cost example. There's great data for California because they've been at it a while. Okay? The cost of nuclear, hydro, or fossil fuel generation is $45 per megawatt hour. Okay? You don't have to know what a megawatt hour is, but you know what 45 bucks is. Okay? And you only need to compare it to the cost of net zero for green generation is $1,060 per megawatt hour, which comes up to a little bit over 20 times the cost to go net zero. So net zero, while feasible if you can get enough materials, and how are you going to mine all the material without diesel trucks? I don't get it, or diesel equipment, I don't get it. So anyway, so there you are. I'm going to give you a couple links to some literature here where this information comes from, technical literature. You can go there if you want. It's not that bad, it's written for the average guy to understand. It's the only reason I can understand it. And disastrous consequences of net zero and cost of battery backup for net zero. The first one references the second one, but anyway, it's easy enough reading. Okay, NYSERDA, and I'm going to go real quick on this. The feasibility study, NYSERDA is New York State Energy Resources Development Agency. Okay, and they've been spending lots of time doing a study on the Great Lakes, and they separate, this Great Lakes is not offshore, offshore is ocean, Great Lakes is Great Lakes. So anyway, they're doing Great Lakes feasibility out there. Wind-wise, the bad news is the best place for a turbine is right in front of my house. But that being said, and there's a link here you can download to get the white paper. The actual report itself comes in like 6 or 7, maybe 8 sections, and there's hundreds and hundreds of pages. But the white paper summarizes it nicely. Okay, it's technical, economic, and environmental effects. Let me go to the executive summary, the very top. Based on the totality of this analysis, this concludes that Great Lakes Wind currently does not offer a unique, critical, or cost-effective contribution toward the achievement of New York State's Climate Act goals. Remember, that Climate Act doesn't get repealed, you're still stuck with it, right? Beyond what existing, more cost-competitive programs are currently expected to deliver. Here's the bad news. What are those other alternatives? All the windmills and solar farms they're putting up. What they're determining is, well, we're going to keep going with you heard about Alley Cat, right? Allegheny Cattaraugus, right? They're going to be jamming these things down our throats. Not on the lake, but up here. So, the conclusion of the study is this. Great Lakes wind projects would be significantly more costly for ratepayers to support than projects currently advanced under Tier 1 of the Clean Energy Standard, blah, 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 such as land-based, wind, and solar. So they just said right there, you can't, on the lake, you can't match the cost of land-based, okay? For example, 2021 Tier 1 solicitation resulted, now look at the numbers, in index REC strike prices, translate that phrase to subsidies, okay? The subsidies, and so between 42 and 63 per megawatt hour land-based to, and remember, these do not include interconnect costs. This is the dirty secret. So if you're ever talking to Tom Mira, straighten him out. And then for on the lake, it would be 98 to 138 dollars per megawatt hour. And once again, and you're gonna have to add a lot of costs to that. So that being said, moreover, that cost differential would increase further because the feasibility study cost estimates of Great Lakes wind do not fully account for additional costs associated with interconnection, infrastructure, and labor, which would require site-specific evaluations and more detailed modeling. So I would say this: the war on taxpayers is not over. This is the best part of the whole presentation. I'm quoting, taking no action now does not mean there may not be an opportunity to advance Great Lakes wind at some point in the future. Yeah, when the subsidy delivery gets up, right? The resource may become meaning Lake Erie and Ontario, may become a feasible contributor to New York State's goals in the future as the state advances toward its mid-century goals, and the Ohio demonstration project in Lake Erie discussed herein may provide further information to help that. So in Ohio, they're putting up a small set of them in Cleveland called Icebreaker, can't wait. But although that's now running into reality problems. So anyway, you've seen this before. This is the guy that was the head of the IPCC. Said, we, the UN IPCC, redistribute de facto the world's wealth by climate policy. One has to free oneself from the illusion that international climate policy is environmental policy. This has almost nothing to do with environmental policy anymore. Bingo, it's 100% politics and money. And the money is being taken from you. And, oh, everybody cheer at this one, right? You're supposed to cheer when you see end of presentation. Okay, anyway, you'll get all kinds of other data here. They'll in the back of this, so like another 30 slides, and Mel won't let me talk about it.
Sense of whales. Thank you, Mike.
Thanks for coming tonight.